Okay, so what did you notice in rings of numbers?
Well, like, there were these different sets of numbers you talked about, like the integers, and then, or the counting numbers, then integers around that, then
Real numbers, I think?
no, these were the decimal numbers, or
Ration.
the rational numbers.
Yeah.
Then
Then irrational numbers, then complex numbers.
I don't think so. Imaginary numbers.
Well, that's complex.
Well,
Yeah, complex numbers are yeah. These are just words that people use, but you have exactly the right idea. That you could start out with what in some sense is a small set of numbers, like
But they're all infinitely big.
yeah, the counting numbers,
So like 1.
and then you could include negative numbers if you wanted, like you talked about,
Yeah.
and then you could include
Fractions.
fractions.
then like square root of 2.
Yeah, square root of 2. And then even up b, right? Good.
Then you get to here, you get like i's.
Maybe like x's, y, x
Oh.
plus y.
Is it the square root of -1 times 7? Stuff like this.
Yeah. Good. Good. And what did you find interesting about that?
Well, that like it's like this set's in this set. It's sort of like a big Venn diagram.
It is kind of like a big
So,
Venn
like,
diagram.
So you have the real numbers, which are in the counting numbers, which are inside the integers, which are inside the real numbers, which are inside the irrational numbers, which are inside the complex numbers.
Yeah. Interesting. And why? Why did he say you would want to study all these different kinds of numbers?
Well,
What
to
was
learn,
the reason?
It was to learn more about the existing set of numbers.
Okay.
Like, I think he gave an example of an equation like x squared plus x plus 1 equals y cubed minus y.
And this has no integer solutions.
So nothing within here would work.
Huh. And why is that? Why were there no integer solutions?
Well, because this is an odd number.
It's always an odd number.
Because you either have x squared, if x is odd, then you have odd, which is an odd number. And if x is even, you have even, plus odd, which is an odd number. And
And
then,
this side is always even.
because y cubed is going to be, if y is even, this is going to be even minus even.
Okay.
And if y cubed is odd, this is going to be odd minus odd.
Okay.
So and these are all for integer solutions. So an odd number never can equal an even number.
Yeah. So just by understanding some ideas, and this, by the way, when he's talking about this, he was even going back to the clock arithmetic, but the clock only had zeros and ones, or 1 and 2,
Yeah.
how you want to look at it, for even and odd. Yeah, so that's interesting. Okay. So for part C, I'm just going to have you guys come up with a single question. Like, what is a question that you can ask about integers that we at this point know how to answer? Okay, that'll be
Alright.
for part C.
Okay.